Welcome back. Today we're looking at surds. Surds. These simply irrational numbers. Irrational numbers. What are irrational numbers? Irrational numbers are numbers that you cannot represent as a fraction. You cannot represent these numbers as a fraction, say A over B. Example of irrational number is square root of 2, square root of 3, pi. Now, pi is really an irrational number because you cannot represent pi as a fraction. Some persons will ask, what about 22 over 7? Well, 22 over 7 is just an approximate value to represent pi. But pi is not exactly 22 over 7. Now for surds, we are looking at all irrational numbers, meaning all square roots except those of perfect squares. Those of perfect squares are rational numbers. Next, we go to the rules of surds. The rules of surds. When you have root A times B, this means it's equal to root A times root B. 2. Okay, the second part that we're looking now is what if you have this? Okay, second rule is root A over B. This is the same as root A over root B. Root A over root B. Now note root A plus B is not equal to root A plus root B standing alone. No, this is not a rule. Now, another one is this: root A minus B also does not equal to root A minus root B. Please, let's take this into perspective. Root A minus B is not equal to root A minus root B. Next, we look at expressing surds in their basic form. Expressing surds in their basic form. Let's take, for example, root 45. To express this in its basic form, this surd in its basic form, remember we said all roots of numbers are irrational numbers except the root of perfect squares. So we look for the highest square that can divide 45. And the highest square that can divide 45 is 9. So we will now change this. This will be 9 times 5. The highest square that can divide 45 is 9. And we know it's 9 times 5 that gives 45. So gradually we break them down just as we have in the rules. Surdic rules, we have this. So this now becomes 3 times root 5 because this is not an irrational number. This gives us 3 root 5. This surd is now in its basic form. Also, let's look at root 162. Square root of 162. The highest square that can divide this is 81, meaning 81 times 2. So this is root 81 times 2. This is the same as root 81 times root 2. This gives us 9 times root 2, which is 9 root 2. We go over to similar surds. Similar surds. Surds which are multiples of the same surds are known to be what? Similar. For example, we have root 3. 3 root 3. 8 root 3. All these are called similar surds because they are multiples of the surd root 3. Another example is this root 10. 16 root 10. These are similar surds. So similar surds can be manipulated. You can add, you can subtract similar surds. Now let's go to the first part. Let's see how we add and subtract similar surds. For instance, if we have root 2 plus 7 root 2 minus 5 root 2. If you look at all these, they have the same surds, so they are termed similar. We can do this in two ways for clarity. You can just go on, you know what you have here is 1, here is 7. Okay, you just bring out the, let's see, 1 plus 7 is 8. 8 root 2 minus 5 root 2. So your answer becomes 3 root 2. Just shows that we can manipulate similar surds. We can manipulate similar surds. Sometimes examiners may want to test a deeper understanding of this by telling you to add root 8 plus root 2. Now look at this. If you notice that a perfect square can divide, you first simplify before you know if they are similar or not. This is same thing as root. The highest square that can divide this is 4 times 2 plus root 2. This will give us root 4 times root 2 plus root 2, which is root 4 is 2, 2 root 2 plus 2. Sorry, plus root 2. This will give us 3 root 2. So we first simplify, then test if it's similar to similar. We'll now add them up together. Conjugate surds. Conjugate means the opposite. Conjugate simply refers to the opposite. For example, if you have A plus root B, the conjugate of this will be A minus root B. Just the opposite sign, the opposite operation. So this is the conjugate of this. This takes us to rationalizing surds. Now, in mathematics, it is not acceptable for the denominator of a fraction to be an irrational number. It is not our custom. So, what we do is we try as much as possible to rationalizing surds. How do we rationalize? The idea behind rationalizing is multiplying it by 1. Some persons will ask, if you multiply by 1, that's the same thing. No, look at what we mean. So if you multiply this by 1, we can say this is same thing as root 2 times root 2 over root 2. Remember, root 2 divided by root 2 is the same thing as 1. So if you multiply anything by 1, it's still that thing. So anything we get out here will be equivalent to that, the question. Okay, so let's see. 2 times root 2 is 2 root 2 over root 2 times root 2 is root 4. So, but this is not a rational number, or this is not an irrational number, sorry. This is a rational number, so we can break it down. The answer becomes 2 root 2 over 2. We can cut them off. The 2 we cancel 2. So our answer becomes root 2. So we have rationalized the surd to give make it in its basic form. What if we have this 1 minus root 3 over 1 plus root 3, something of this nature? How do we go about it? The first thing, like I said, you multiply by 1. But that one you're multiplying with will be the conjugate of the denominator. Will be the conjugate of the denominator. So this becomes times 1 minus root 3 over 1 minus root 3. Having said that, we go on to show them that this is same as 1 minus root 3 all square over, remember, this now becomes difference of 2 squares. Difference of 2 squares. A shorter way of doing this is the first one here, square them, minus, you square this. Difference of 2 squares. The next thing you do, you expand the numerator here. In expanding the numerator, you have 1 minus 2 root 3 plus 3 over the denominator. You have 1 minus 3. Moving up, we now have some rational forms. So we can say this is same as 1 plus 3 is 4 minus 2 root 3 over minus 2 over minus 2. So we can have it as this. Very quickly, I will factorize so that I can get it quickly. So if I divide, my answer becomes root 3 minus 2. I want you to look at it and try and get how I simplify this to give me that. So that is the answer. What if you are given this? What if you are given this question? Simplify 3 over 1 minus root 2 plus 2 over 1 plus root 2. Let's look at this question. You're given to simplify that. Let's see the first step. When you're given a positive sign here or a negative sign, you also actually look for the LCM. So let's see. Let's look for the LCM. This gives us 1 minus root 2, 1 plus root 2 is the LCM of the denominator. Now, let's see. When we divide the LCM by 1 minus root 2, we have 1 plus root 2. Then 1 plus root 2 multiplies the numerator here. It becomes 3 into 1 plus root 2. Same thing happens here. If you divide the LCM with 1 plus root 2, you have 1 minus root 2. 1 minus root 2 times 2, you have this 2 bracket 1 minus root 2. That's the second step. Let's see. Let's go on to the third step. Now we expand the numerator. You have 3 plus 3 root 2 plus 2 minus 2 root 2 divided by, remember, difference of two squares. You have 1 square minus root 2 all square. Root 2 all square. Now this becomes 3 plus 2 is 5. Root 3 root 2 minus 2 root 2 is plus root 2 over, this is 1 minus 2. 1 minus 2. So this is 1 minus 2 is negative 1. So this is negative 1 into 5 plus root 2. So this gives us minus 5 minus root 2. This is our answer. This is our answer. Okay. This is our answer. Now, what if you're asked to find the square root, positive square root of a surd? Say, find the square root, root of 28 minus 10 root 3. You want to find the square root of that. Sorry about that. We want to find the square root of that. Now, for us to find the square root of that, we will need to go this way. The square root of that number will be something like this. Root A minus root B all square gave us 28 minus 10 root 3. Definitely something like this gave birth to that. So how do we continue with it? So what we do is this. We expand. Let's expand this. It gives us a minus 2 root ab plus b, which is equal to 28 minus 10 root 3. Please, I want you to look at it. So this means a plus b minus 2 root ab gives us 28 minus 10 root 3. 28 minus 10 root 3. Invariably, we can juxtapose them, or we can place them side by side, meaning that a plus b equal to 28. A plus b equal to 28. This is our first equation. That's our first equation. And just a minute. And minus 2 root ab equal to minus 10 root 3. Yes. And that means if you divide both sides by 2 and remove the bracket, this root, you have a b equal to 5. Okay, root ab, let's put it back so we don't get confused, equal to 5 root 3, equal to 5 root 3. So we can say we square both sides. Squaring both sides, you have AB equal to 25 times 3. AB equal to 75. Second equation. Second equation. With this, having known this, we will now go on to say that A can be termed as 75 over B. We will now substitute this in equation 1. Now let's continue. This now becomes A plus B from equation 1, which is 28. But A is 75 over B. So this becomes 75 over B plus B equal to 28. Let's clear fraction by multiplying through by B. So this is 75 plus B square equal to 28B. Let's rearrange. This becomes B square minus 28B plus 75 equal to 0. Look at this. We've gotten a quadratic equation. We can go on to simplify this. Now, there are two ways we can do this. You can either factorize or using your formula method, or even using completing the square method, depending on the one that your choice. It depends on your choice. So for me, this is B square. I have two factors of 75 because the equation of B square is 1. Two factors of 25 that will multiply themselves to give you 75. Two factors of 75, but they will add themselves to give you negative 28. So I have this should be 3b and 25b. I've just split the middle part into 2. So I will factorize what the HCF of this is b. You have b minus 3, and here you have what is common here is 25, and you have b minus 3 equal to 0. Equal to 0. From this, we know b minus 3 is common, so you have b minus 3 and b minus 25 outside equal to 0. We know b minus 3 equal to 0, or b minus 25 equal to 0. So b is equal to 3, or b is equal to 25. Now we've gotten the values of b. So if b is 3, what is a? So when b is 3, a becomes 75 over 3, which is 25. Or when b is 25, a becomes 75 over 25, a becomes 3. So we've gotten the values of a and b. So the roots are, or the root of the equation is this: root 25 minus root 3, or that is, you have this 5 minus root 3. You can do it the other way. You have your answer. What if you're finally given an equation, an irrational equation like this? Simplify or solve root x plus 2 minus root x minus 1 equal to 1. Oh, x minus 3, sorry, equal to 1. You're given an equation of this size to solve. Okay, what's the first thing you to do? So the first thing I will do here is this. First, I will make this equal to a, or x plus 2, and b to equal this. Or I will go straight and solve it. Since we're dealing with surds, I will just go straight and solve it this way. This will give us root x plus 2 equal to 1 plus root x minus 3. I will now square both sides. This will give me x plus 2 equal to, if I square this side, okay, let me do it this way. If I square this side, this will give me this, so you don't get confused, all squared. That's the first step, so you don't get confused. Now, remember, if you have this, 1, okay, a plus b all squared, this would be a squared plus 2ab plus b squared. So I will also use that here. So this becomes x plus 2 equal to 1 square plus 2 times 1 times root x minus 3. Then I have plus root x minus 3 squared. I believe you understand what I just did. Okay. Let's continue. So this is x plus 2 equal to 1 plus 2 root x minus 3 plus x minus 3. So let's see the next step. Comes 2 plus 2, 2 plus 2 equal to 2 root x minus 3. So this is 4 equal to 2 root x minus 3. So this will give us, divide both sides by 2. This is 2 equal to root x minus 3. So let's square both sides. You have 4 equal to x minus 3. So we have this to be x equal to 4 plus 3. So our answer is x equal to 7. 7 should be the answer.